Hey there! C# is a great language, and it keeps getting better each year, which makes it all the more unfortunate that as Unity developers, we're stuck with C#9, which was released more than 5 years ago. But what if I told you we can use C#14 in our codebase? In this video, I'll explain how to do that, what will work and what won't, why Unity doesn't do that themselves, and I'll start by showing you a couple of language features you've been missing out on. But before we begin, hit that like button, subscribe, and turn on the notification bell so you won't miss more videos. And now, buckle up. Unlike .NET versions, language versions usually only add syntactic sugar. And the first feature I'll show you focuses on reducing boilerplate code. Those of you who usually work with DI frameworks are probably used to code like this, but you don't need a DI framework to benefit from it. When we want to initialize a plain C# class with one-time parameters, we pass them through a constructor and initialize class-level fields with them. As an additional optimization and safety step, we can mark those fields as read-only. Later on, we can access those fields anywhere inside the class, like in my dummy spawn method here. I can enable the view or play a sound, and I can even log that the player has spawned. C#12 introduced a new feature called primary constructor. It's a new syntax that allows you to skip all of the boilerplate code, like in my example here, and reduce it to a single line. What I'll do is just copy the constructor signature here, delete the constructor and the fields, and paste the copied code immediately after the class name. This makes the parameters of the constructor accessible everywhere inside the class. But this comes with a trade-off. Unfortunately, those parameters are not immutable and can be overridden, so they don't really replace read-only fields. If I need immutability, I have two options. The first one, I can introduce read-only fields that will be immediately assigned to the primary constructor parameters. As you can see, Rider even has a shortcut for this that's also renaming the usages. While this approach will add a little bit of code, we're still saving the boilerplate code we used to have inside the constructor. But with this option, even though Rider will alert me that this is wrong, I can still override the value of the parameter, and from compiler standpoint, it'll be completely valid. The second option has been available since C#9, and you can even use it today in your project, although with a slight hack. It's the record type. All I need to do here is change the class keyword to record, and now all of the parameters turn into immutable properties. I probably need to create a video about records, but in short, a record is a class, or a struct, designed for immutable data, where equality compares the values inside rather than the reference of the object. The second feature is less about boilerplate and more about code readability and clarity. Let's say, for whatever reason, I've decided to not use a layer mask and created an enum representation of my layers instead in order to use them in a serialized field. You know me, I love stupid examples. Now, if I want to assign the enum to the layer field of the game object, I need to cast it to an integer. If I want it the other way around, I'll need to cast the layer property to my enum. This is a one-liner and doesn't really need too many clarity improvements, but for the sake of example, we can use the extension methods you're probably familiar with. I can have an extension method called setLayer that extends the game object and accepts the game layer enum as a parameter. Internally, it does the casting, and I can do the same with getting a layer, a simple extension method that returns the enum converted from an integer. Now the invocation is a little bit more readable. I can access both extension methods directly from a game object and set or retrieve a value. In C#14, there's a new way of writing extensions. It's called extension members. Just like with the old extension methods, it all starts with a static class. But then there's a new keyword, extension. This tells the compiler that we're writing an extension block that allows us to create multiple extensions inside. Next, I'm specifying what type will receive the extensions inside the block. Game object in my case. And now I can start writing extensions as if they were part of the type itself. I can move the extension methods inside, remove the static keyword, and remove the this keyword along with the game object parameter. Why? Because we already have it in the extension declaration. But that's not all. I can also create a game layer property that encapsulates this whole logic. The same logic as in the methods, but in more compact form. Now I can access this property as if it were part of the game object. Even though the syntax is a little bit different than what we're probably used to, I really like this feature. Another cool thing we can do with extension members is static extensions. Let's say I want to create a helper method for a list of integers that creates a new list with values from 0 to some number. I can do it with a simple static method. Then I can access the static method through the static class and get the result. It's great and pretty readable, especially if you invest into properly naming your static classes. Not like me here. Thanks to extension members, I can arguably make it better. I start the same way as before, telling the compiler that the extension is for a list of integers. By the way, generics also supported, and you can use them by passing a generic parameter after the extension keyword. But in my case, I don't really need that. Now I can copy the static method here and properly name it, let's say with range. What this allows me to do is access this method as if it were a static method declared inside the list class. Pretty neat, huh? There are a lot of features we're missing out on, and if you'd like to see more content on modern C# features, let me know in the comment section. Let's see how we can start using them in Unity. But this is not just a how-to tutorial. I want you to understand how it ticks before you do any change. So let's talk about a Unity feature that makes this whole thing possible, the csc.rsp file. CSC stands for C# compiler. The RSP is a response file, contains arguments that get passed to the compiler. You need to place this file next to an assembly definition, and Unity will use these compiler arguments when building that specific assembly. The most common use case? Enabling nullable reference types, but you can also specify the language version. There's an issue with that though. Even if you write lang version 14, and even though Unity ships with Roslyn compiler, it's outdated and doesn't actually support this language version. So the first obstacle is the compiler version Unity ships with. But let's say we overcome this obstacle. Let's say we found a way to update the compiler version, and we already know how to pass it parameters that instruct it to compile the assembly with a specific C# version. There's the second obstacle. The IDE doesn't know that we're sending some parameters to the compiler. It can work with the latest and greatest C# version if we tell it to, but first we need a way to tell it to. The way to do it is to modify the csproj file, and we can do it either manually or through the IDE UI. If we try to use features from a language version above the configured one, we'll have compilation errors in the IDE, while Unity will compile just fine. Unfortunately, we can't just change the csproj file because with every compilation, Unity regenerates it and any changes we made will be overridden. So the second obstacle is that we need to constantly update the csproj file with the correct language version. I was thinking on creating something like this myself, but then I found this repository by Karim Andreychuk on GitHub. It does exactly what I described earlier. But before installing it, let's talk about the elephant in the room. What are the dangers of doing it, and why Unity never did it themselves? First, and most importantly, the patch modifies your Unity editor installation. This means all projects using that editor version on your machine will be affected. The other project will still use the default C# version for compilation, but from the newer SDK. So if you have projects that rely on specific compiler behavior, this could cause issues. It should be fine, but should and will are two different words. Second, not every C# feature actually works in Unity's runtime. Some features require BCL changes that Unity's mono runtime doesn't have. The package README has a detailed table showing what works and what doesn't. For example, generic attributes will actually crash your game. The static abstract members in interfaces from C#11 won't work, and some features will need a source generator called polysharp to fill in missing APIs. It all boils down to personal responsibility. Nothing will stop you from using unsupported features. The compiler will think everything is okay until it isn't at runtime. So, if my previous statements haven't answered the question of why we don't have this out of the box with Unity, I'll try to simplify the answer. First, as you can see, there are a lot of features that aren't supported even if they bump the compiler version. And Unity doesn't really have a way to limit those. Second, every new feature requires quality control on both the mono and the I/O to CPP runtimes. Multiply that by the enormous amount of platforms Unity supports, and you'll get an idea of how much work it is. Unity is actually working on a solution, but we'll probably see it only by the end of 2027 or even later. Bottom line, most users don't need it, but those who do will have no problem enabling it. If everything I've said earlier hasn't scared you off and you still want to install the package, let's do it. But personally, I take no responsibility whatsoever for any issues it might cause. First, you need to make sure that you have the latest .NET runtime. The patcher itself doesn't come with its own Roslyn compiler. Instead, it copies the compiler binaries from the official .NET SDK distribution to your Unity editor installation, which is good. Next, let's add the package to the Unity project. We go to Window, Package Management, and then Package Manager. Here, I can click on the plus icon and choose to install the package from a Git URL. Make sure to provide the latest version at the end of the URL. After Unity has recompiled, close it. That's important. Now we're approaching the danger zone. We need to navigate to the package installation folder in a terminal. And while I'm doing it on Mac, the process should be similar on Windows and Linux. You can find the package by going from the root of your project, then Library, then Package Cache, and then a folder named after the package with some numbers at the end. Now we need to navigate to Edit or Patch folder inside. Note the tilde at the end of the folder name. The last step is to execute the patcher. We do this with the .NET command that installed along with the .NET SDK. Unity Editor Patch DLL is the file we're executing, and then we need to pass it some parameters. The first one, apply. This will apply the patch. Later on, if you want to revert the change, you can run the same command but with the revert parameter instead of apply. Next, we need to specify the editor location. By default on Mac, it'll be inside Applications, Unity, Hub, Editor, and then the editor version. If you installed it in another location, or you use in Windows or Linux, just find where you installed it and provide the correct location here. Lastly, hit Enter and watch it run. It'll check what SDK versions are installed on your machine, and as you can see, I have a lot of them, and then it will take the latest and copy its files to your Unity installation. The last part is to create the CSC/RSP file just like I did before. While theoretically you can drop this file in the root of your project and it'll affect all assemblies, this is not recommended. Newer C# versions introduced new keywords that might be used as variables inside your or third-party code you're using. So the better approach is to place this file alongside every assembly that you want. So I'm placing it next to my assembly definition file. And that's it. After Unity recompiles, you can start using modern C# in your project. Personally, I love being on the bleeding edge of technology. But if you're working on a live service title that has thousands or even millions of users, these experiments can be dangerous, so tread with caution. Don't forget to like, subscribe, and enable notifications because it really helps the channel grow. Keep on creating, and I'll see you in the next one.